Hello, it's John Vaughan, and welcome to another exciting adventure of C++ programming. Um, this is session 10. This is for operator overloading and a little bit about the string class. Um, the I'm going to be going off of the supplementary material primarily that I published on the site, and the coverage of the class is chapter 10 of the class textbook. It's significantly more verbose. It has quite a bit of information in it. Um, I just say become comfortable with overloading operators. Um, but obviously you don't have any tests coming up, so I'm not going to test you on the finer points of it. But C++ has you have the ability to do what's called overloading operators. Now, what this means is you can actually define what does it mean, or what does a plus symbol mean, for example, or what does the which is the addition operator, or what is the minus symbol, which is the subtraction operator. What do those mean relative to certain types of data? For example, if I defined a dog class and I wanted to define what does it mean for two dogs to be equal, or what does it mean for me to add one dog to the other. Maybe you want to generate puppies. I don't know. In many programming languages like Java, you can't overload operators, so you end up with extra methods or member functions to perform similar tasks. Okay, but to make things more natural in C++, they do allow operator overloading. So first things first, we'll see an example of where operator overloading is present in a class that's already defined for us. In this case, it's the string class. Okay. So we're going to include string and iostream. And we'll take a look at how it's overloaded, how different operators are overloaded for the string class. So for the string class, let's say I have one string, which is my name, first name, and then string s2 is my last name. And if I want to, just to expand this a little bit, let me say I want to say it's s1 is now equal to s1 plus the plus a space. Okay, this is the same as if I were to say s1 plus equals a space. Okay, so those are identical. Now, with numbers, we are used to using the plus and the plus equals operator, the compound assignment operator, and addition operator to add a number. For example, if I have a variable int a equals 5, and then int b equals 2. If I later on say a plus equals b, then we know that that's going to take the value of a and then add the value of b to a. Okay, this is equivalent to a equals a plus b. Right? I could write either of those. So we know that the addition operator and the compound addition assignment operator are defined for integers. Okay, we know that they're also defined for doubles, and a very, very kind and intelligent set of programmers defined the plus symbol for us with strings, okay, and the equal sign as well. What we have here, when I apply the plus symbol to a string, is it performs what's called concatenation. So concatenation. I believe we mentioned that in an earlier session, but I want to make sure that it's clear what that means. String concatenation means you're taking two strings and you're basically splicing them together. Okay, so I'm taking one string, for example, s1, and I'm appending the s2 to that string. Or well, in this case, a blank space to the string. Now, let's say I want to now take s1 and append s2. I can use the plus equals, or I could again likewise S1 equals S1 plus S2. You can do it either way. I'm just showing you a mix of different ways to do it. Now, these are not defined by the C++ programming language. Okay, these operators were overloaded by a developer or developers for us. Okay, so a couple things to keep in mind are that the related operators, you have to define them separately. For example, when you define the plus symbol, or when they defined the plus symbol for strings, it did not automatically take care of the plus equal symbol. They had to define what do both mean. Okay, so that's one thing you can do. Now, if I now see out S1, we're going to get, hopefully, my full name. Okay, build succeeded. We're going to run it, and I, as expected, get my full name with a space in between because we added the space. Right? We appended the space. We concatenated S1 with a space, and then we concatenated S1, which then included the space with my last name, which is an S2, string 2. Okay, so that's how operator overloading works with strings. It's already made for us. The next thing we're going to cover are first the rules of operator overloading, and then we'll actually look at an example. We'll make a full-fledged example where we define a class and overload some operators. So the rules of operator overloading is that you have to operate or overload the operators explicitly. That's one rule, because it doesn't occur automatically. That means just because you define, it may make sense to you. If you, let's say you define a custom string class, it may make sense to you that using the plus symbol, as we have here, would concatenate an additional string to your string class. Okay, that may make sense to you, or your string object, but it doesn't happen automatically. The compiler has no idea what that means. And if you have a class and you try to add two objects of your class, or an object of your class and something else, if you try to add them and you have not defined that operator for those for that class, then you're going to get a compiler error. It won't even compile. So the different rules of operator overlaying. So an operator, you have to define what are called operator functions. In order to overload operator, they take a very similar syntax to a member function, and they don't need to be a member. We'll talk about that. You have to have a non-static member function. Okay, so you can't have a static member function, or you can have an entirely non-member function. Okay, that function would have to be, if you define a function for operators, you would have to, if it's not a member function, you would have to define it outside the class, and it would have to be defined as a friend, or declared as a friend inside of the class's specification file. Okay, so if it's a member function, you don't need to worry about it. It's inside inside. It's a member function, just like any other member function. If it's outside, you have to declare it as a friend, just like you would any other function. So, and there are reasons why you would want to have a non-member function. That's one of the reasons that friends come in handy and actually are sometimes extremely useful and necessary in C++ is for defining, for overloading certain operators, like when you add two certain types together, and the one on the left side isn't the type of your object. Meaning, if you define an operator as a member function, then by default and by necessity, what we call the left-hand side of the operator, left operand, has to be an object of your class. Well, you don't always want that. You might want certain different behavior if, say, you have a double on the left side and then an object of your class on the right. You might want to change that, right? So if that's the case, you have to define it outside of the class as a friend. Okay, so That's covered in the book if you want to, if you're interested. Now, regardless, the name of the function is the keyword operator, followed by the operator being overloaded. For example, if I type operator plus and with no space in between, that means you're overloading the addition operator. Okay, so some notes about operator overloading. You can overload most operators in C++. You cannot create new operators. You can only overload existing operators. And then there are 4 operators that you cannot overload. For example, the dot, which is the member access operator, the dot star, which is pointer to member, the scope resolution operator, which is 2 colons, and then the conditional operator, which is the only ternary or 3 operand operator in C++ cannot be overloaded. So those can't be overloaded. You also cannot change the precedence of an operator by overloading it, or the associativity. And you can also not change the arity of an operator. For example, if you have an operator that's binary, in other words, it takes 2 operands, okay, you cannot overload it to be unary. All right. Related operators such as plus and plus equals, for example, so the addition operator and then the compound addition assignment operator, have to be overloaded separately. You cannot assume just because you've overloaded the plus symbol that the compiler, the runtime environment, knows what to do with plus equals. Those are 2 different operators as far as the system's concerned. And when overloading the parentheses, the square brackets, and the arrow operator, or any of the assignment operators, the operators must be declared as class members. Okay, you can't declare them outside and as friends. Okay, so I'm going to delete this stuff involving strings, and we're going to get started with a fresh class. I'm going to add a header. Okay, we've done this about 1 million times now, right? So we should know how to do it. Incidentally, you could go to File, New File, and add a file that way, but this is just way quicker, in my opinion. Right-click, add. You could just add a class directly, but I usually like going to Add New Item and then selecting a header file. In this case, well, in this case you'd want a header file, but for the class you could just add a class. But I'm going to call this rectangle.h, and then we're going to also add to the source files. I'm going to add a new item, and it's going to be rectangle.cpp. So we've dealt with shapes before, and we're going to deal with them again. Rectangle.h, I'm going to define using if-in-def. Now, I had a question from a couple different people about these include guards here. And in a nutshell, it might be a little bit complicated to understand, but in a nutshell, what this is doing is that this is a preprocessor directive. That means this is read before the compiler itself is actually run. This is read. Anything with the pound sign in front of it. That's why the include statements work. So the preprocessor actually inserts the information from these libraries so you can access data within them. Data and functionality. So the first thing we do is we put the include guards here, because that happens. Let's say if we have another class called cube, and cube makes use of rectangle because it's set of rectangles essentially, or maybe we have rectangle list or something like that that makes use of this. And let's say in main we make use of rectangle and the rectangle list. Now if you include rectangle inside of rectangle list, and then you include rectangle inside of main and include rectangle list inside of main, that means you're technically trying to include this header twice, because it would be written twice. It's written once because you explicitly say I want rectangle.h. It's written a second time because it's part of rectangle. It's part of the rectangle list class. Let's say if we have one. So basically, this just prevents multiple inclusions. Okay, so if you don't really understand it, just use it as is, and maybe it'll become more clear as you program for a while. There are some topics where people might think I'm just doing a cop-out here, but there are some topics that are not going to make a ton of sense until you've been programming for a while. And then when you come back and revisit these topics that were quote-unquote intro topics, they make a whole lot more sense down the line. Well, for the private part of the rectangle, the private section of the rectangle, we just need the length and the width, which I'm going to define both as doubles, okay? Because they can have floating point values. All right. So for the public, I want two different constructors. I want a default constructor if they don't specify parameters. Then I'm going to make another one which takes double width and double length. And then additional member functions. We're going to do set length, which takes one parameter. We're going to do set width, which takes another parameter, and we're going to get add some get methods. So get length and get width. And notice I'm putting const at the end. Do you remember why we do that? Okay, do you remember why we do that? If I were you, I'd pause the video and think about why do we add const to the end, okay, before I give it to you. Okay, so we add const to the end of the get length and get width because the const basically means you're making a contract, or this method is making member function is making a contract with the class saying I will not modify any of the private data. Now that doesn't mean you can't use the private data. You could multiply something by it and then return that value or do a calculation with it. That's fine. It just means I'm not going to change length, I'm not going to change width. That's what the const at the end means. That's why we do not have const at the end of set length and set width, because these by necessity and by their very invention modify the length and the width. Okay. Also, we want to have a get area and get perimeter. All right, and we're going to have an obligatory helper function, which is a print function. Okay, so what are the differences between the get length, get width, and likewise the get area and get perimeter? So I want to make a distinction between these two and these two. What's some major difference you can think of? Okay, again, you might want to pause for a couple minutes and then think about it. Well, the difference between these two, or between these two collectively and then these two, are that these return data that are directly kept as private data. Okay, these two, on the other hand, on the fly, as they are called, we'll have to calculate a value. We are not keeping the area and the perimeter in the private data. We're not keeping those values in the private data, because this could change if the length and width change, and we can derive these values from the length and the width, correct? So that's why those are slightly different. We will make use of length and width, but we do not modify them. That's why all four of these, or all of these, are const, including the print function. Now, for overloading operators, we're going to have four. We want to overload the plus, the multiplication, the equals comparison, and the not equals to comparison operator. Okay? So let's think of what's going to happen. If I have a situation where I have a rectangle 3 is equal to rectangle 1 plus rectangle 2, or rectangle 4 is equal to rectangle 1 times rectangle 2. Well, how are we going to define that? Well, the plus symbol, whenever you define a member function, such as the addition operator right here, which we're going to define as an operator internal here, it's going to assume that the left-hand operator is us. So this may be a little bit squirrely to think about, but when I use this command, I say R1, it's actually R1 that's going to be performing the addition. That's the one actually calling the, what we call the operator function. Okay, so what's it going to return? Ultimately, what's going to be returned from the addition of two rectangles? Right? If we add two rectangles, we're going to define it as adding the lengths and adding the widths respectively. Okay, so what does that mean? Well, what that means to us is that it's going to return another rectangle. Okay, because we're going to add the lengths and the widths and then return this new rectangle for the user to capture or just let go. So rectangle is a valid return value. Okay, rectangle. And I have operator plus. Notice there's no space, and notice that operator turns blue because it is a keyword. And then I'm going to pass in a parameter and then put const at the end. Well, let's look at the syntax very carefully here. Rectangle is the return value, just like with any of these methods. I could make a method called return add or whatever, and I wouldn't even have to overload the operator, but it's really not that complicated. The syntax is just the keyword operator and then the symbol that you're overloading. The parameter would be whatever's on the right-hand side of this operator if it's a binary operator. So right here it would be, in this case, R1 is actually performing the operation. R1 is assumed to be the rectangle in question. The plus symbol will cause it to go to this addition operator, and then the parameter is another rectangle, which would be R2 in this case. Okay, const means we are not going to modify the rectangle itself, this particular rectangle, meaning R1 will not be modified, none of its data will be modified. Even though we're returning a separate rectangle, we are not modifying R1 itself. Okay, now why are we passing in a const rectangle? I could put an R there, it doesn't really matter. Why am I passing in a const rectangle at reference? Well, I'm passing by reference because I want to be able to access the data, and it's actually smaller to pass a reference than it is to pass the whole thing. So that's why I do this. But why do I make it const? Why is it made const? That's because I don't want the function to actually be able to modify the rectangle passed in. In other words, if I try to modify R2, this will cause a problem because this is declared as const, so a compiler error will be flagged. If I try to modify R1, this const will cause a compiler error because, again, just like these methods up here, I've made a contractual agreement with the class that I am not going to modify the data inside the class. Okay, so we're basically making sure, the reason these two are consts is that we're making sure that we are not going to modify either of the other rectangles in question. We're just going to return a third rectangle. Okay. Now the next thing is another operator. This time the multiplication operator. We're going to define it as well. Const. And then we have two comparison operator. Notice those return bool, and they also do not modify either rectangle in question. Operator not equal to const rectangle ampersand. Notice for both of these I didn't even put a variable name here. This is acceptable because in the header file you don't have to actually put any of these. I could delete length or delete width here, not down here obviously, but in here in the parentheses, because really the header file just needs to know how many parameters and what are their types. That's all it needs to know. It doesn't really need a name. But, you know, out of stylistically, a lot of times I'll do this. I don't think I did in the example in the case study. In fact, I didn't. But you can. It doesn't really matter. Okay, so let's actually define this here. So we've got everything we need here. We've got all of these. I'm just going to copy this, and we're going to go into rectangle.cpp. I'm going to include rectangle.h. I'm going to paste all this, and then we'll get to work making it look a little prettier. And also, I'm going to go over to main and include rectangle.h as well. Okay, so first thing is I want to put in the name of the class and the scope resolution operator. I'm going to put that in front of each of these. Okay, each of those. Get area, get perimeter, print. I'm going to delete this stuff so it's a little cleaner. Rectangle. Okay, now be very careful with the operators because you might get confused because there's the word rectangle here. That is the return type. Okay, to use scope resolution, I have to put that in front of each of the keyword operators. Okay, next thing is I delete the semicolon. Now, could you do all this from scratch? Absolutely. If you wanted to, that's fine. But I just find it quicker to, especially when you have a ton of member functions, to do a copy and paste approach. Okay, I'm just deleting the semicolon off the end of each of these definitions. You may still get an error for those that are supposed to return a type and aren't, or return value and don't just yet. Okay. All right, so it's a lot of stuff. Okay, so now, what do we want to do for the constructor? Well, for the constructor, we're just going to say that the default width is 0 and the default length is 0. Now, I could also say, again, remember referring to your own data members, I could say this arrow width. Okay, and then this could be this arrow length. All right? Now, this isn't so much important here, but here it becomes crucial if we're going to keep these names width and length. Because if the parameters, again, we've gone over this a couple times, but I want to reiterate it because it's very important. If the parameters have the same names as internal data members, you have to distinguish between the external data member, for example, width, and the parameter width. So this one, okay, so the right of the equal sign, this represents the parameter that's passed in, and then the left side, since we have appended this and then the arrow operator at the front, the member access operator, through via pointer, then we have basically said this represents the object that we're in, and then width is our private data member. So same thing with length. Okay, so that's pretty straightforward. Set length is really just part of the aforementioned constructor that we were working on. So it's essentially the same thing. So those two are pretty straightforward. Get length again. Now, since here we're not contending with a parameter with the same name, we can just say return width because it's the only width in scope. Oh, sorry. That was supposed to be length. Okay. All right, so we've got set length, set width, get width. Area of a rectangle is width times length, or length times width, doesn't really matter. Perimeter, we're going to, just to make it a little bit more clear what we're doing, even though it's not really necessary to do this, you have 2 times width plus 2 times length, right? And then print, what we're going to do with print is we're going to make kind of a useful utility function that's really not doing much except for printing out the length with area and perimeter. So we've got length, which we print out the internal length, and then an inline, and then notice cout, it's having a trouble with cout because we have not included IOStream, so we need to include IOStream at the top. Okay, now it should be cleared up there. Okay, again, back to print. Width, and area, I'm just going to call get area instead of redefining or doing the formula. And perimeter, okay, there we go. That's all print does. All right, now we get to the interesting stuff, the operator overloading. Well, the first one, remember that we can interact with our own data members, but we can also actually interact with the members of R, which is the right-hand side of this, whatever the expression or equation is. So we're going to make a rectangle called temp_rect, and then I'm going to say temp_rect.length. Okay, this is the rectangle we're going to return. Okay, that's why we have the return type rectangle. This is the one that's going to be the resultant rectangle. So we have to define what does this plus symbol mean. So it's equal to our internal length plus R, which is the right-hand side of our equation, that rectangle, So we're going to add the two lengths, and then same thing with the widths. We're going to take our internal width and then add the width of the other rectangle, and then we're going to return that rectangle. Okay. The multiplication symbol is pretty much identical, except we're going to say temp_rect here. Again, I could do a copy and paste job here, but we're going to do a little bit more, a little bit nicer here. Okay, length temp_rect dot width equal to width times r dot width, and then return 10. Right. All right, so those two they're pretty straightforward. Again, once you understand the syntax of the header, the actual what it's doing is not really that complicated. Now equals is not really more complicated, but we're going to return what does it mean for two rectangles to be equal? Well, we're going to define it as both the length and the width must be equal. Okay, so that means my length, meaning the left-hand side of the operator, has to be equal to the right-hand side's length. The lengths have to be equal, and the widths have to be equal. So that means if my length is equal to r's length, and, because we want both, my width is equal to r's width, then we know that it's going to return. It'll return true if this whole thing's true. It'll return false if this whole thing's false. You could use an if statement in here, but this is actually the shortest way to write it. Just realize that since the equal sign, this may look a little bit squirrely and confusing here, but since length is a double and r's length is a double, we're using the equal symbol in this context, comparing two doubles and two other doubles. Okay, and the same thing with the not equal to is that it returns. If the length is not equal to r's.length, or the width, my width, is not equal to r's width. So you only need one of them to not be equal for the whole thing. So if you have a 5x5 rectangle and a 5x6 rectangle, even though both of their widths might match, or lengths might match, that even if the widths are not the same, that means the rectangles are not the same. So all you need is one of these to be wrong, or to be different, not both of them. Okay, so that's so far so good. We've got basically our class defined now. And, you know, I don't think I put a main function in here. Oh, well. Well, it's probably a good thing then we've done this. Okay, so for main, I'm going to define a rectangle. I'm going to call it rect1. And I'm going to have another one, rect2. And then another one, rectangle rect3. Okay, so for rect1, I'm actually going to change its constructor so that it has 20 and 10, because we do have two constructors to deal with. And oh, it's got a copy constructor. Okay, then we'll do a 5 and 2. Okay, and rect3 I'm going to leave alone for right now. Rect3, we're also going to make rect4, rectangle rect4. Okay, so rect3 I'm going to set equal to rect1 plus rect2. And then rect4 I'm going to set equal to rect1 times rect2. Okay, so let's do this. Let's say rectangle 1, and I'm going to call rect1.print, and then I'm going to do an end line. Okay, I'm going to do this for each of the rectangles, so I'm just going to do a little copy and paste action here. Okay, this is rectangle 1, rectangle 2. I have to change both the call and the, oops, it should be 3 this time. I have to change the call and what I'm printing out, so rect4, and we'll see if this actually works. And I run it, and not surprisingly, we get what we expect. Okay, so we get the first one, or the rectangle 3, should be the addition of the two lengths and widths, which it is. 10 plus 2 is 12, and 20 plus 5 is 25, which is why we get 12 and 25. The other one, you multiply them, so that's why we get 10 times 2 is 20, and then 20 times 5 is 100. Okay, so not surprising. You could also test, if you want to test the equals operator, we'll just say if rect1 is not equal to rect2, CF rect1 and rect2 are not equal. Okay. And let's say I have a rectangle rect5, and I'm going to make that 20 and 10. Okay, I'm going to say if rect1 is equal to rect5, I'm going to print out rect1 and rect5 are equal. Okay. We could add some else's here, but it doesn't really matter. We just know that it's either going to print or not. So that's what we'll deal with right now. Okay, so it does say rect1 and rect2 are not equal, and it says rect1 and rect5 are equal because the lengths and the widths match. So we have successfully defined the addition operator, the multiplication operator, the not equals to comparison, and the equals to comparison operators. So we've defined that for rectangle. All right. So that's pretty much what this chapter is about. The next thing I want you to do is on your own as a study. I'm actually going to post this, or I'm going to post. It's posted in the. It's posted in as a notes for session 10. It says to look into the date class in section 10.8 of the book and see if you can get the class to work properly. So just try to basically you're just regurgitating the stuff just to make sure that you can write the class and get it in the environment and get it to compile and get it to work. Okay, so I'm trying to think if there are any questions. We can check the discussion board real quick and see what we got going on. What do we have going on here? Okay. Okay, looks like there's a new message since then. Let's see here. What we got? This is live television here, so I don't know if I'll have an answer for you right off. Okay, that might be a specific problem. Well, since stream insertion operator is not found, no operator shakes a right. Yeah, you can't. Okay, this question right here is asking about the printing out the vector. You can't print out the vector in total. I can't say something like cout and then less than or equal to whatever the name of the vector is. You have to go through a loop, and you have to print out each individual item in the vector. Okay. Couple areas, but I have my class and binary. Okay, well, I'm gonna for that, Miss Devaney, I'm going to need some code. I'm not sure what's going on with your second part. Okay, so there are other topics that were recently added that I'd like to go over too. Okay. I want to show all of these. Huh. All messages. Why is it not? Are you the only one that's posted in here? I think you are. Okay. So there were a couple questions I think on programming, maybe still on programming project 1. Let me look over it real quick. A couple of people asking if I'm in my office. Well, you know, if you by the time you get this video, you probably don't won't have a chance to visit me. But I did post a news article to let everyone know that I was going to be here. Okay, questions about the class. There were a couple from yesterday, I think. Oh, this is a big thing that a couple people are having troubles with. It says, I've noticed in your Project 2 template you have a customer constructor statement. In that area, do we want to apply initial conditions or be able to add new employees? For the constructor, you technically don't have to do anything at all, really. If you're maintaining a length separately, then you'll have to declare that length there or define it there. The vectors, other questions that I got was how do we work with vectors and array? If you want to do a get function for an array or a vector, you can actually have that as the return type. Just as I showed you here that you can have rectangle as a return type, because it's a class, you can have a vector as a return type. So a vector of integers, a vector of strings, whatever. It says, which file do you put the array or vector in? Well, it's private data for a class. So you're going to put it in the .h file, in the private data section, just like you would with anything else. Okay, so that seems to be the question so far. If you have further questions, it looks like Programming Project 2 is due this week on the 12th, I think. So that looks like a few people are having trouble. I'm going to probably ping the class and find out if a lot of people are having trouble. And if a lot of people are having trouble, I may be inclined to set the due date a little bit later. But we'll see what happens. So if you have any questions, please feel free to email me. I will try to get back to you as soon as possible. Post in the discussion board. I try to check that at least every day, or at worst every 2 days. But if something is negligent on my part, like you didn't get something answered within a amount of a time and something was like due, I wouldn't recommend asking me at 11:58 p.m. and then getting upset with me because I didn't answer it by 11:58 and 30 seconds on Friday. So if it's within the last hour or last couple hours before it's due, I may not get to it right away, but I also am pretty lenient as far as people turning in stuff. As long as you turn it in pretty much on time, you're pretty set. So, all right, well, thank you, and if you have any questions, again, email me, and have a great week.